Hello everyone. In this class today we are going to discuss about the term energy. Students, whenever we talk about the energy, we say that energy is something that can make an object able to do the work. For example, electricity make fan capable to rotate. Petrol make capable a bike to move. Then we can say the energy is something which make a body capable to move or capable to do work. Here we can write energy is the ability to do work, or the amount of energy possessed by a body is equal to the amount of work it can do when its energy is released. It's a scalar quantity, we all know, and its unit is same as the unit of work, and it is joule, and its CGS unit is arc. You all must know about other units just like calorie, kilowatt hours, then electron volt, and so many other units are there. 1 joule is equal to 10 to the power 7 arc. Students, we can classify the energy in different forms. Mechanical energy has two classification: potential energy and kinetic energy. दूसरा heat energy, third one is the light energy. Sound energy, 5 chemical energy, electrical energy, magnetic energy, nuclear energy. Then these type of energies are available. In our syllabus in class 11th, we will discuss about the energy of mechanical energy. We will discuss about the mechanical energy, whose first type is kinetic energy. Kinetic energy, we all know very well, the energy possessed by a body due to its motion. Then you can read the definition. Kinetic energy is defined as the energy of a body by virtue of its motion. And we can see it is the measure of work done by a body by its motion. It means when a body is in the motion, then the energy possessed by it is called kinetic energy. For example, a moving wind can rotate a windmill. Flowing water, it has a kinetic energy. A fired bullet, it can penetrate a body, it has an energy. Then the energy possessed by the moving bodies who are in the motion is called kinetic energy. You can see the examples. Moving cricket ball, now let us discuss about the formula of kinetic energy, which we have discussed in class 9th. Students, there was a very famous formula of kinetic energy, that is half mv square. Kinetic energy is equal to half mv square, where m is the mass and v is the velocity. Then we will derive this formula. Suppose you have a body and you applied a force on that body. Then what happens? That force displaces that body. I repeat again. Consider we have a body whose mass is m, and we are applying a force F on that body, and that force displaces the body. Definitely there will be a gain in velocity. Whenever you apply a force, there will be the gain in velocity, and due to the displacement, the work done will be the force into displacement. We have a formula of force. Force is equal to mass into acceleration. Displacement is already there. Now students, you can measure the mass, you can measure the displacement, but you can find the acceleration using the equation of motion. Then here we are using the third equation of motion, that is v square is equal to u square plus 2as. And from here, by substituting the value, you will get the value of acceleration. Here you can, from here you can get the value of as and substitute this value in equation number 1, from where you will get work done is equal to half mv square minus u square, where v is the final velocity and u is the initial velocity. If the body is only at rest, then u will be 0 and the answer is kinetic energy is equal to half mv square. You can see the kinetic energy is directly proportional to the mass of the body and directly proportional to the square of the velocity of the body. If you double the mass, kinetic energy will be doubled. If you halve the mass, kinetic energy will be half. Then students, whenever you find any result, try to analyze that result and try to find that how a particular quantity depends on the given quantity. From here you can see kinetic energy is always positive. This is the very key point. Kinetic energy is always positive. Why? Because mass has a positive value and there is a square of velocity, and whenever you square something, it will be always positive. Kinetic energy is a scalar quantity, as we have discussed already. Now students, we will discuss a very important theorem, that is the work energy theorem. Work energy theorem, students, using this concept you can solve so many numericals. Work energy theorem states that whenever you do a work on a body, then this work done goes to change the kinetic energy of that body. And see this. Suppose a body of mass m is moving with velocity u, initial velocity is u, acted upon by a force F for time t, and let the gain in the velocity is v and displacement is s. Then we can use the third equation, and from here, if you multiply the both side by m and half, if you multiply the both side by m by 2, the result which you are getting, that is half mv square minus half mu square is equal to mas, where ma is the mass into acceleration is the force. Then what you are getting, half mv square minus half mu square is equal to force into displacement, and we all know force into displacement is equal to the work done. Then from here you can see half mv square, v means final velocity, then it is the final kinetic energy. Half mu square, it is the u is the initial velocity, then it is the initial kinetic energy. And from here we are getting work done is equal to kf minus ki, means final kinetic energy minus initial kinetic energy. And this is the work energy theorem, and it states that work done on a body goes to change its kinetic energy. Then that's all for today, students. Solve the numerical problems from NCERT. Thank you for watching.